Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors 10-1 homework solutions on right triangle trigonometry. For this problem, I'm trying to find this missing side of a right triangle, and I've got one more side, an angle, so I'm going to use SOHCAHTOA. And let's see here, based off this angle, I have the adjacent side. I've also got the hypotenuse, so that gives me ka out of SOHCAHTOA. That means I need cosine for this one. So I can write cosine of theta in general equals adjacent over hypotenuse. So that means cosine of my angle, 30 degrees, equals the adjacent side x over hypotenuse 8. Now to solve for x, I have to multiply 8 by both sides. So 8 times the cosine of 30 is going to give me my answer. Let me run that on the calculator. So let's do 8 cosine 30. And all this time it's in degrees. That's the nice thing about the Desmos scientific calculator. It defaults to degrees. So that's going to be 6.9 roughly. To find this missing side, since I have one more side and an angle, I'm going to use some SOHCAHTOA. Looking at my angle of 60 degrees here, I've got the opposite side from that, or at least I'm looking for that, and I've also got the hypotenuse. So opposite hypotenuse, OH, that is the SO part of SOHCAHTOA. So that means I'm going to use sine equals opposite over hypotenuse. So I can write sine of 60 degrees equals opposite side x over hypotenuse 6. And in order to solve for x, I just multiply both sides by 6. So 6 times the sine of 60. Let's see what that comes out to. So 6 sine of 60 comes out to 5.2. In order to find this missing side x, since I have an angle and another side in a right triangle, I can use SOHCAHTOA. So I've got, based off this angle, I've got the opposite side and the adjacent side. So I need TOA, tangent, equals opposite over adjacent. So I can write tan of 45 equals opposite side x over adjacent side 8. So then 8 times the tan of 45 is going to give me my x, and I can run that on the calculator. I happen to know tan of 45 is 1, but let me run it on the calculator. So 8 tan 45 comes out to 8. 8 times 1. For this problem, I'm trying to find the missing angle over here, and I've got the hypotenuse and the opposite side. So opposite hypotenuse, that's O, so that's going to be SO from SOHCAHTOA. So sine equals opposite over hypotenuse. So I have the sine of the x that I'm looking for equals the opposite side 14 over hypotenuse 16. And then I need sine inverse of both sides to get the x. So x equals sine inverse of 14 over 16. So let me do sine -1 on Desmos here, and then let me do 14 over 16, and that comes out to 61.0 degrees. On this problem, they want us to solve the triangle, given the diagram and the two pieces of information here. Let me start by actually labeling my diagram. So angle A is 27, and side B is 9 right there. And now I'm going to find the other missing sides and angles. Now I don't have to find angle C because that's a right angle. I do need to find angle B, however. So because I've already used up 90 degrees over here, that means that there's 90 left over for these other two angles. So that means B must be 90 minus the 27, the complementary angle. And that comes out, I believe, to 63 degrees. I'm also going to find sides A and C. And I'm going to use the 9 and the 27 to do both of these because I'm guaranteed that these two pieces of information are correct versus anything I might find along the way could have gotten it wrong. So based off of this information, side A is opposite the angle they gave me, opposite 27, and side B, which I have, is adjacent. So opposite, adjacent, that's going to be the TOA part of SOHCAHTOA. So I can use tangent equals opposite over adjacent to find side A. I can write specifically tangent of 27 degrees equals opposite side A over adjacent side 9. And then to get a, I just need to do 9 times the tan of 27. And then if I run this on the calculator, 9 and tan of 27 comes out to approximately, they wanted nearest hundredth actually, so 4.59. All right, let me go ahead and find side C now. Since I have sides A and B, I could use Pythagorean theorem to get it, but I'm going to use SOHCAHTOA again because, again, the 9 and the 27, I know for a fact those are correct. So let's see here. If this is the hypotenuse and 9 was the adjacent hypotenuse based off of this angle, that's cosine of theta equals adjacent over hypotenuse. So cosine of 27 now equals adjacent side 9 over hypotenuse C. Now to get C by itself, I have to multiply it to this side and then immediately divide by cosine of 27. So I have C equals 9 over the cosine of 27. Let me go back to Desmos to figure that out. So let's do 9 divided by cos 27. And that comes out to about 10.10, so 10.10. For this one, we have a ladder leaning against a wall. The ladder has an angle of depression of 74 degrees, apparently. And if the foot of the ladder is 65 or 6.5 feet from the wall, we want to know how long the ladder is. So ladder leaning against a wall, but they said we have an angle of depression. So I'm going to do an upside down triangle. But when I do this, it's a little bit weird. You have to visualize. Here's my ladder. That's this hypotenuse here. But the wall is actually over here to the left. So the angle of depression they're looking for is this angle in here. It's always between the horizontal and the hypotenuse. So we have an angle of depression of 74. That's this angle. The foot of the ladder is 6.5 feet from the wall. So that would be this distance right here. Here's the foot of the ladder, here's the wall, but it corresponds with this horizontal distance up here. So this is where I'm putting my 6.5 feet. And then how long is the ladder? That's this hypotenuse distance. So I've got the hypotenuse. I am looking for the adjacent side with respect to this 74-degree angle. So adjacent hypotenuse, that's cosine equals adjacent over hypotenuse is what I'm going to use here. So I can write cosine of 74 degrees equals adjacent side 6.5 over hypotenuse x. And then to get x by itself, I'm going to multiply both sides by x and then immediately divide by cosine of 74. So I've got 6.5 over cosine of 74. Let me run that on the calculator. So 6.5 divided by cosine 74, and I'm in degrees for this, and that's coming out to about 23.6 feet. For this one, in order to reach the top of a hill, which is 250 feet high, one must travel 2,000 feet along an inclined road which leads to the top. We want to find the measure of the angle of elevation. So elevation, let's do a right side up triangle here. Our hill, this is the top of the hill, and this is the road we're traveling on to get to the top. So this is 250 feet above the base here. And then this road itself is our 2,000 feet. And we want to find the angle of elevation, so that's this angle in the lower left between the horizontal and the hypotenuse. All right, so I've got the opposite side over here from the angle, and I've also got the hypotenuse. O and H, that's the SO part of SOHCAHTOA. So sine of theta equals opposite over hypotenuse. So sine of x equals opposite side 250 over hypotenuse 2,000. To get the angle then, I need to do sine inverse of both sides. So sine inverse of 250 over 2,000. And if I run that on the calculator, I do sine -1 and then parentheses 250 divided by 2,000, and that should come out to about 7.2 degrees. So pretty shallow angle of elevation as these things go, although maybe for a road that's kind of steep. For this problem, they actually gave us a diagram. You're hiking near a canyon. While standing at A, which is right here, you measure an angle of 90 degrees between B, which is somewhere on the same side as you are, and C, which is somewhere on the other side of the canyon. You then walk to B. You couldn't walk to C, right? You walk to B, measure an angle of 76 degrees between A and C. So that's this lower left angle here. The distance between A and B is about 2 miles. I mean, you could easily measure that in your walk. We want to know how wide the canyon is between A and C. So it's kind of, this darkness here looks like the canyon, but maybe there's more to it, just the way this picture is drawn. Maybe this is the actual side, the other side of the canyon over here, and this is all just kind of that inner wall. Anyway, we need this distance here. This is x. So based off of the angle that they gave me here, x is the opposite side, 2 is the adjacent side. Opposite adjacent is going to be a tangent situation, TOA. So tan equals opposite over adjacent. So specifically, I can write tan of 76 degrees equals opposite side x over adjacent side 2. And then to get x, I just do 2 times both sides. So 2 times the tan of 76. Let's run that on the calculator. 2 tan 76 in degrees mode gives us about 8.0 if I take it to the nearest tenth. So that's 8.0 miles from one side of the canyon to the other. That's pretty far. You're not walking that.